Hello fellow Padawan, I just finished the very first useful version of my Atari 2600 kernel and I just thought I should show you a little footage. Before of my exams I developed some part of the guy, but for now I was more into the core, to the stage of low-level programming where I was always better at. First I had to write my own assembler to convert my assembly source code into binary, and you won't believe me, that was the easier part. Now I want to talk about what this kernel is capable of. The 2600 is very limited and the biggest challenge is to fit all the things you desire into that small amount of time you get each scanline, and you have to be pixel precise, literally. What you can see here is the main kernel. There are no other screen elements like scoreboards, indicators, static images whatsoever. The kernel can display 42 lines of playfield. It's pretty static since it's loaded from the RAM, but as only 4 bits are used by the PF0, I can put 2 different values into the same byte, so if I change it during the scanline, I can add some variety. The only thing I cannot demonstrate now is that the playfield is indexed, so you can scroll it vertically, giving the illusion of a bigger stage. Also, I added coloring for the playfield and the background, and since it's a free line. Okay, I already have to update this. As you can see, every single line of the playfield can be colored, and it's also scrollable because it's attached to the index of the playfield. Of course, you don't have to waste 42 bytes for every single time you want to make a flat pattern. The environment will generate it once, and the next time only the pointer has to be set to that. Since there's always a base color added to the line color, you can change the feeling easily. For example, you can create static color lines and add some brightness to it and change it as you wish. Or you can make your own brightness pattern and add a base color to it, so you can create variety for each stage. There are only 2 sprites, but you can change the color for each line. So I added some fake colors, so if a missile is not in the same line as its player, it can have a unique color. I added some built-in features which are performed in the VBlank, so don't accept too many free cycles for your own code here. First, the sprites are stored as a line of animation and they can have 16 frames for each, of course if they are not exceeding 256 bytes. So for looping your animation you only have to set the indexes and it's calculated here in the VBlank. The other feature handles the situation as the objects try to leave the screen. You have 3 choices. The first one will stop the objects on the sides. The second one will make them appear on the opposite side. There's also a mix option which will stop the players at the side, but the missiles will go through and appear at the opposite side. I'm pretty sure you are really interested in how much RAM I have wasted for this. But to tell you the truth, in the conventional RAM section you have 65 bytes of RAM just for your taste, much more than Battery Basic ever offered, and also there's an empty Sarah waiting for you. And as I mentioned earlier, this framework only supports 32K RAM with Sarah included, but I'm pretty sure it's much more than any game that's suitable for the 2600 needs. Thanks for watching, hope I can connect you with some improvements soon, see you later!